lesson is on adding and subtracting rational expressions. So just like our warm-up where we were looking at adding and subtracting fractions, I need a common denominator in order to put these together. But this time I'm going to find that there's some algebra either in the numerator or the denominator, or both. So we're going to move through some questions, progressing from some easier ones to some more difficult ones. In the first question, this is a bit simpler because I don't have any algebra in my denominator. I just have 3 and 6. So again, I'm just thinking to come up with my lowest common denominator, going through all the multiples of 6 and all the multiples of 3, and I notice that 6 is in fact my lowest common denominator. So there's nothing that I need to change about the first fraction. But the second fraction, I want to change this so that I get a 6 on the bottom. And I noticed that in order to do that, I had to multiply the 3 by a 2. So that tells me that I need to multiply the numerator by 2. So multiplied by 2, I need to multiply by 2. Be careful that you multiply the whole numerator by 2, not just the first term. So now I've got x plus 3 plus 4x minus 3, and it's all over, 4x minus 6. Don't forget to multiply the whole numerator by 2. And it's all over the same common denominator of 6. I'm going to collect my like terms on the top, so I have 5 x's, take away 3 over 6. I'm going to think about stating restrictions, but here there's no variables in the denominator, so no restrictions for me to state. Moving on, getting a little bit trickier, we're looking now, I have some algebra in the denominator, but nothing too complicated. Again, I'm going to start by looking for my lowest common denominator. And I'm just thinking through first the coefficients. So my coefficients are 2 and 6. So if I think through the multiples of 2, the multiples of 6, the first one they have in common is 6. And then thinking through the x's. So I have 1 x in the first denominator, so I need at least 1 x. But the second denominator requires 3 x's, so that tells me that I do need to have 3 x's. So I know that my lowest common denominator is 6x cubed. That means the second denominator is going to stay the same. I need to figure out what do I need to multiply that first fraction by to come up with 6x cubed. And I can see here I need to multiply the 2 by 3 to get 6, and I need x squared times x to give me the x cubed. So if I multiply the denominator by 3x squared, I need to multiply the numerator by 3x squared. The second one is not changing because we already have the denominator that we were hoping for. So I can simplify this first numerator, and I'm going to multiply the 3x squared into the bracket. And then I'm going to subtract this entire second numerator. Again, my denominator is simplified to 6x cubed. So don't forget that I am subtracting the 2x and the 3. That leaves me with 3x cubed minus 3x squared minus 2x minus 3, all over 6x cubed. Now there's no common factors, there's no like terms in the numerator for me to collect. There's also no way for me to factor that one nicely. So there's nothing that's going to cancel out. So I'm as simple as I'm going to get, and I just need to state my restrictions. Now the only denominators that I had was 2x and 6x cubed. In both of those, the only restriction is that that x cannot be equal to 0. So again, restrictions are coming from what would make the denominator equal 0. In part C, a little bit trickier because now we have 3 fractions, and our denominators have some addition and subtraction. Don't forget that when it's linear like this and there's no squared on the m's, I can just put brackets around those and think of those as individual factors. So my lowest common denominator in this case, there are no repeated factors. The only factor in the first fraction is m. The only factor in the second denominator is m plus 1. And the only factor in the third one is m minus 3. Remember that the factors, I can't separate the addition. So the entire second factor is m plus 1. That tells me that the only way to get a lowest common denominator is to multiply those three things together. So remember, factors are multiplication statements. So I need to change my first fraction, 2 over m, so that it has my lowest common denominator. That tells me that I need to multiply the denominator by m plus 1 and m minus 3. and so I have to do the same thing to the numerator. Moving on to the second fraction, I'm just going to put those factors in brackets, the ones that we already have. My denominator is missing an m factor, and it's missing an m minus 3 factor. That tells me that I also need an m factor in the numerator and an m minus 3 in the numerator. And then finally, I'm adding the last fraction. I had an m minus 1 over m minus 3. My denominator is missing an m factor and an m plus 1 factor. But if I multiply the denominator by that, I also need to multiply the numerator by that. And now I'm going to start simplifying these things. So when I'm subtracting these numerators, I'm just putting them all over the same denominator. I'm just going to move that m to the beginning and put the brackets with addition and subtraction at the end. And when I add and subtract all those numerators, it's all just over that common denominator that I selected at the beginning. Now I'm going to try to simplify this numerator to see if there's any way for me to get this down a little bit smaller or simpler. So I'm going to leave the 2 out front of the first term, and I'm just going to multiply m plus 1 times m minus 3. Now, as I did that, I also collected those 2 middle terms. I had 4 terms. I had a plus 1m and a minus 3m, and I added those together. If that's confusing for you, make sure you take that extra line and FOIL it out, get the 4 terms, and then collect the like terms. It's not worth it to save the time if you're just going to make a mistake. When I looked at that last one and I got m squared minus 1, what I noticed was that this original statement looked a whole lot like the difference of squares answer. So I know that when I actually put them together, I would get something that did look like a difference of squares. Just watch for those little patterns. It'll make you feel better that you know that it should have ended up looking that way. Now I'm going to multiply each of these coefficients into the brackets. So I'm doubling everything in the first bracket. I'm multiplying negative m into that second bracket. Don't forget about the negative sign. And then multiplying positive m into the last bracket. Still all over the same common denominator. Now I'm going to try to collect some like terms. And one of the things I notice is that I've got an m cubed minus an m cubed, so that equals 0 m cubes. So that's going to go away, and I'm just left with 3m squared. And then for my m terms, I have negative 4 plus 6. Take away another one, so plus m minus 6, all over my common denominator. Now, what would be really slick is if that numerator also factored and one of those factors canceled, like what we saw yesterday with multiplying and dividing. So I'm going to take a look at my numerator and ask myself, can I get a product of the first times the last, negative 18, and a sum of 1 in the middle? So I go through all my products of 18. So I'm thinking about negative 1 times 18, negative 2 times 9, negative 3 times 6. And I notice that none of them are going to give me a sum of positive 1, even if I switch the signs to have the negative on the other term. So this does not factor. But I'm writing it down so that my teacher knows that I thought about it and I was trying to simplify as far as I can. The last thing I need to do is state my restrictions on my m's. So I'm thinking about each one of those factors in the denominator, the m plus 1, and the m minus 3. And I want to make sure that none of those 3 will equal 0. So I see from the middle one that m cannot equal negative 1. From the first one, m, I can see that m can't equal 0. And then from the last one, m minus 3, I can see that m cannot equal 3. Moving on, we're going to try and make it a little bit more difficult. Looking at D, I can't just simply pop some brackets around the denominators. I need to actually factor those statements. So I've got some simple trinomials here, which tells me I'm just looking for 2 numbers that multiply to negative 6 and add to positive 5. And then in the second fraction, I'm looking for 2 numbers that multiply to negative 2 and add to positive 1. Now when I'm looking at these factored expressions, I can find my lowest common denominator. To do that, looking at my first denominator, I see that my lowest common denominator needs a factor of a plus 6, and it also needs a factor of a minus 1. Looking at my second denominator, I see that my lowest common denominator needs a factor of a plus 2, and I don't have an a plus 2 factor yet. So I'm going to tack that on the end. And then looking at my second denominator, I can see that I need a factor of a minus 1, but I already have an a minus 1 factor in my lowest common denominator. I don't need to repeat this, or I'm going to end up making my denominator and my numerators bigger than they need to be. So I'm already done there. I have all the factors I need. So in my first fraction, I have the a plus 6, I have the a minus 1, but I'm missing the a plus 2 factor. So I need to multiply by a plus 2 on the bottom and on the top. Then looking at the second fraction, I have the a plus 2, I have the a minus 1, but I'm missing the a plus 6 factor. So I need to multiply by that in the denominator and the numerator. Now I can put the two fractions together by subtracting the numerators. At the same time, I am going to expand the a into the first bracket. And then I'm subtracting 2 times everything in that second bracket. So subtract 2 times a and subtract 2 times 6. Don't forget that that subtraction goes with both terms. And then I'm still all over my common denominator. I'm going to try to simplify my numerator, and I can see here that the 2a minus 2a, that's going to cancel out and give me 0 a's. And I'm just left with a squared minus 12. Still over the same common denominator. Now I'm checking to see if that numerator factors, to see if I can cancel a factor top and bottom. So here I'm looking to multiply to the last number. That means I need a product of negative 12. And I need to sum to the coefficient on the a, that middle term. But we ended up with 0 a's. So I need a sum of 0. So when I think through all the products that give me negative 12, like negative 1 and 12, negative 2 and 6, negative 3 and 4, I notice that none of those are going to give me a sum of 0, even if I swapped the negatives to the other side. So I cannot factor. And I'm done here. I just need to state my restrictions. So thinking about my restrictions, I'm thinking about my very first factored denominators. So don't worry about trying to figure out what the restrictions would be when it's unfactored. Go to the spot where you did factor them. So I can see here that a cannot be negative 6, a cannot be 1, a cannot be negative 2, and a cannot be 1, but we've already listed that. So I'm going to put those 3 in order from smallest to biggest. And I'm done with that question. Moving on to our last example, second last example. Part E here, we've got, again, 2 denominators that need to be factored before I can find my common denominator. So I'm going to leave the numerators, and I'm asking what are 2 numbers that multiply to positive 1 and add to negative 2, and that is x minus 1 squared. And then I'm going to subtract, and I've got x plus 2 over, I've got a difference of squares here, so x plus 2 and x minus 2 in the denominator on that one. Now, before I get started here, I am going to start canceling within the fractions. Don't forget that you can simplify within a fraction. And I see here that I've got an x plus 2 on top of another x plus 2. That simplifies to 1 over x minus 2. And same within the other fraction here. I've got x minus 1 over 2 x minus 1s, or x minus 1 times x minus 1. So again, I can cancel one of those brackets from the top and the bottom. I can't cancel across subtraction, right? So I would not be able to go from the numerator on one fraction to the denominator on the other because I need to have a times sign in between for that to happen. So I'm just going to rewrite here what I have already simplified, 1 over x minus 1 and 1 over x minus 2. Now I'm going to start looking for my lowest common denominator. I've already made it a little bit simpler for myself. What I notice is that there are no common factors. The first factor in the first denominator is x minus 1, and the second factor in the second denominator is x minus 2. So the simplest thing I can do is just multiply those together. That tells me that I need to change the first fraction so that it has an x minus 2 also being multiplied. If I do that in the denominator, I need to multiply the top by x minus 2. And then the second fraction, it already has an x minus 2, but it's missing the x minus 1 factor, so I'll multiply top and bottom by x minus 1. And then I'm just going to subtract these fractions. So in the first numerator, I had x minus 2, and then I'm subtracting 1 times everything in that bracket. So subtract x and add 1. Be careful that you take that subtraction through to both of those terms. My common denominator is still the same. Oops, I changed it to a plus. And now I'm going to simplify my numerator. I notice that I have a positive x take away an x. That's just 0 x's. And I'm just left with negative 1 in my numerator. So that's as simple as I can get there. Now to state my restrictions, I need to go back and take a look at all of the brackets that were in the first factored denominators, because I didn't cancel some stuff that still matters. So when I look at the first denominator, when I factored it, I saw that I had x minus 1 times another x minus 1. That means that x can't be 1. And then looking at the second denominator, x minus 2 tells me that x can't be 2. And x plus 2 tells me that x can't be negative 2. So watch that you don't forget to come back and look at those canceled factors. Again, listing those in order, I'd have negative 2, 1, and 2. And that's it for your last lesson.